Hi everyone. Today's topic is going to be built on top of Angular signals. We saw the talk from DJ, we learned what signals are, effects, computed link signal, after render effect, what the live consumer, non-live consumer are, how we can use those. Good. So the other title I'd say of this talk is synchronizing the world with signals inside our application. Basically meaning that we will see how with signals, everything that happens on the outside can be converted into something reactive inside our applications. So we don't have to synchronize anything ourselves. Angular does it for us. And we will see basically Angular's evolution towards, let's say, a more reactive and synchronized model. I'm Enea Jahollari. I work at Push-based. I work on large migration support, performance improvements, and of course, scalable Angular architectures. I'm also a GD for Angular, core maintainer at RX Angular and NG extension. So today's topic's going to be a little bit of dependency injection, providers, destroy ref, signals and reactivity, synchronization, then building on top of them, and a short demo. Let's start. Dependency injection. We all know what dependency injection, I guess, is. We are all Angular developers here. We can do three types of, let's say, dependency injection in Angular, from the constructor with inject function and use factory dependencies. Of course, we all know what this code does. This just injects user profile state and, of course, injects some token with the optional decorator and, of course, using types and such. The thing is, Angular also has this new way since version v14 called inject. Inject basically allows us to access DI anywhere within an injection context. Don't mistake it with reactive context. It's injection context. And of course, with inject, we move DI away from constructors only. So we can do DI not only on, let's say, classes, but also functions. For example, we can have inject function that injects state. So the same thing as before, but now shown with inject function. Of course, because now we can use it in function, it opens the door to have more, let's say, function-based, let's say, architecture in Angular by using functions even more. For example, here's the auth guard that basically allows us to protect our routes if the user is authenticated or not. But instead of, let's say, injecting classes, creating a constructor, putting an injectable there, we just use inject, a function, and that's it. Every time that, let's say, path matching happens, this guard runs. So it's just a function, no need for classes. Of course, we can use also it in HTTP interceptors. Same thing, you can use inject, we don't need a class for it. Also, before we were able to, we still are, in fact, to use dependency injection by using the depths array inside the use factory. So we can have depths, HTTP client, and then inside use factory, we could get those dependencies. And during the, let's say, injection, let's say, provider creation of that token, we could inject those dependencies and use them like normal DI injection. But with inject, we don't need those. We can just call inject inside use factory. And that's it, easy. Well, so with inject, we have a modern way to access dependency injection. It simplifies also class and component directives. And of course, crucially, enables function-based composable features. And that's what we will look at today. And of course, on v20, it will be recommended way to do dependency injection. Providers. Take a sip. Let's say we have Bootstrap application with an app component, and of course, inside its providers, we put user profile state. By doing this, we tell our application that every component inside this Bootstrap application, in our case, which is only app component, but also all its other, let's say, children of app component, now can have access to user profile state. If we have a user profile module and we put it on providers there, our imports or also declarations on that module will also have access to that user profile state service. Same thing for routes. We can now also put providers into routes. By doing that, we give access to all the children routes to have access to that provider. And this really enabled some really cool state management features that we can have with Angular, let's say v16, I guess, later. Well, what else? Yeah, we all know that we can use providers in components, but still there. This basically allows us to inject that provider inside the children of that, let's say, in our case, user profile component. So this allows us to provide, let's say, some store in a component or in a route, let's say, and we can inject that on every other children component and, of course, access the same state. Well, providers. So we have Bootstrap application, ng module, component, route provider, and, of course, providers that are just provided in root services. OK, so why do we care? Why the intro to injection and providers? Well, because we have to know when an injector scope gets destroyed. And of course, an injector scope gets destroyed. In our case, for example, we have Bootstrap application, ng module, route providers, and provided root that are destroyed only when the application is destroyed. And most of the time, that's when you close the tab. So during your application lifetime, probably never. And of course, we have injectors that are destroyed when the component is destroyed, of course, like component providers, directive providers. So this we need to, let's say, take into account when we start providing providers and using some of these new functions that we have today in Angular, for example, like effect. If we use effect in a provided in root service in Angular, that effect will never get destroyed. And of course, that can cause issues. The challenge, why do we care? Manual cleanup. All this time we have to, I don't know, call unsubscribe on our subscriptions. Do something like, I don't know, create a subject and do take until that subject and inside ng destroy, kill it. Or DOM event listeners, like remove event listener if we need to have this really, let's say, to do event listeners using RxJS instead of Angular so we can run them outside Angular and stuff from ng zone, of course. Or timers like clear interval, clear timeout and stuff. Easy to forget, of course, to unsubscribe from this, let's say, never-ending listeners. And of course, this causes memory leaks. So we know all the ng on destroy hooks, so where we can say, hey, when this component gets destroyed, do something. And of course, the issue is we cannot use ng on destroy on functions, so we cannot benefit from function composition features. And of course, it only works on classes, and classes require inheritance to work. So we can reuse them or reuse specific features. We have to extend them. And of course, this means that we cannot reuse cleanup logic of components with ng on destroy. That's where destroyref comes in and says, hey, I'm your savior. And destroyref is the unlocker of automatic or reusable cleanup ability in Angular. Basically, it's a token, or call it a service, that provides us access to the destruction lifecycle of its injector scope, meaning that you can use this in a component or a service. And what it will do is, every time that that injector scope gets destroyed, remember that we had those application providers or component providers, and the only component providers make sense to use destroyref most of the time. So think about it like run this cleanup code when this part of the DI tree is destroyed. So we can just inject destroyref as a class, and we can use it inside constructor or ng on init or everywhere because we have access to it, of course, and then we can run any kind of cleanup logic we need. For example, if we have some user history that we want to populate from some observable, we can store that subscription directly in constructor. And of course, at the same time, unsubscribe when the component is destroyed inside the constructor. We don't need that ng on destroy hook anymore. So this way, we also co-locate the subscription and unsubscription. So we know that we have subscribed and unsubscribed, so no memory leaks will happen there. Well, I can say that with inject and destroyref, we can really create some powerful, let's say, features in Angular. And one of them, for example, is effect, after render effect, and a lot more hooks that are after next render, for example. And those are all possible because we have inject and destroy ref. Those were two key building blocks of those features. And for example, we can use them for injecting some external state. For example, we can say, here's a function, inject some external state. Of course, inside of it, we can inject destroy ref and inject because they allow it. And of course, we can subscribe to some external state. And of course, also clean up in the same place. So we can group all this logic together. Of course, in the end, we can either return some external state or do some side effects that don't need anything to be returned. And of course, we can use it as normal, like external state equals inject this external state. Or inside injectables, because we can maybe provide this injectable service or state or store inside a component provider. And we know that when that component is destroyed, this injector gets destroyed, means that destroy ref will, let's say, call that on destroy hook, meaning that our subscription will get cleanup. So it's something that really enables us to clean up everything safely. Of course, don't forget, it's still tied to the injector where it's provided. So if you provide this state in, I don't know, Bootstrap application providers, that thing won't never be cleaned up. This means that we can reuse cleanup logic through the application without having to use inheritance. We don't have to extend the class to do some logic there to clean up or do subscriptions in order to reuse some state. Good. What is the last piece of the puzzle? Any idea? Well, signals, of course. And of course, the reactivity they bring, their reactive context. We saw DJ, so we know what a signal is, what a computed. We know that computed computes, memoizes, stores, let's say last computation stuff. We know effects, where every time a signal inside of them changes, of course, they rerun that computation or side effect function. And of course, it always reacts to it. So by using set timeout or using some micro task, not micro task, only set timeout, only then it will probably fire. Of course, we all know this, learned it on the previous part. So change detection. That's another piece. And of course, I won't talk about it too much because Pankaj will talk later about local and zoneless change detection. So I'll skip for now. I will only show one slide. Since I learned that Angular can do this, think of it like only detect changes on the component that read a signal and that signal changed, nothing else. Like, for example, on that leaf component there, since I learned that Angular can do this, like only change detect what's changed and nothing else, I wouldn't call it change detection anymore because it doesn't change detect too much now. It only change detects only what's changed or only what needs to be checked. So Angular is in a safe path again, and that's why we now call it synchronization, because it mostly like synchronizes code, or let's say signals in our case, with the DOM. So let's say we have double computed, and then we have a button, a click that updates the count that computed depends on. And let's compile this to just normal JavaScript code, and then see why that matters. If we compile this, we probably will have the same count signal, and of course double computed. We can create divs, just document, create element. And then we have also our event listener that updates that, let's say, signal. And then we can have one effect that says every time that the double, that is a computed signal, changes, then just change this text content. Nothing else. You don't need anything else. This means that every time our signals change, our DOM will get updated, like normal update on the DOM, nothing else. So think of the template as it's running inside an effect. When its signal change, the template will update. And that's why I think this is one of the most powerful things Angular has done since, forever. So basically with synchronization, we have updates that, let's say, update our view or DOM. But what's the other thing? Let's say we have HTML inputs, where we have an input with a value that uses count signal, of course, and we read it on the template. And then, of course, we say, on change of this input, please set the count to this event target value. Let's compile it again to see what happens. Well, we just add an event listener with a change, and of course, count.set event target value. But don't forget, we still have that effect. So every time that count changes, we also update the input value. So it's like synchronizing. And of course, we can do better. We don't have to use value and change. We can use ng-model. I love two-way data binding, and with ng-model, we can safely say input ng-model on the count. And of course, that count is a signal. So we can use signal directly inside ng-model. Every time that input changes, that count will get updated. And every time count gets updated, that ng-model, let's say, will apply those things to the DOM. So now we have this writable signal, which, let's say, in the same time also updates DOM. So it's like synchronizes. And then synchronizes, in this case, is Angular. I won't say Angular change detection. I'd say Angular synchronization. And of course, what I want to say with this is that the framework now speaks in signals language, meaning that if you use it inside a template, it knows that you used a signal inside the template. So you can really remove all your change detection issues if you just use signals. Because Angular will make sure, no matter what, if you use onPush or not, if you use a signal and that signal updates, well, your template has to be updated because, as I said, think of it as it's running inside an effect. Well, there's also two-way binding native signal support. And that's called model. Model basically allows us to do the same thing as before. Let's say we have a counter component where we show count, but in order to create that count, instead of saying a signal, we say model. By saying model, we can now, let's say, tell Angular, I want to create an input and output at the same time, but also use this thing for two-way binding. We can call that as a signal. It's a normal signal under the hood. And of course, we can call set or update on it, so same as the other signal, but now it will also act as an input and as output and as two-way data binding that we did before. And this is, for example, the usage from the parent component where we have counter. So we use count on the banana in a box, and that count, of course, comes from our model. And we have value, which is now a signal. So we have two-way data binding from the child component to the parent component, and the parent component now says, I have a signal that I want you to synchronize with this. I don't care how you do it, you just do it. And that's all Angular's responsibility to do that. And of course, value now is a dependency also for double. And double is part of the template. And when counter changes the value, double also has to recompute. And when double recomputes means a new value. And that new value means, hey, we have an effect. And that effect needs to update the DOM. So it still synchronizes everything without us having to care to synchronize state or values. So not just updates the view on DOM, but also updates our signal state. That's embracing, of course, two-way binding to the fullest. So we don't have to think twice about using it. It's because the framework embraces it and has its, let's say, in its, let's say, core. So let's build on top of DI, signals, and synchronization mindset. First, bridging worlds. We have signals, we have RxJS. I love both. I want both to use them all the time. So let's see how we can do that, of course. We have to signal. We can convert observables to signals by saying user equals to signal, and of course, user $sign. So what this allows us to do is say, hey, I have an observable that is of type user, and I want a signal out of it because Angular speaks better in signals because it understands them better and optimizes them better. So give me a signal out of that observable. And of course, that gives us a user null. We can also pass an initial value to that signal, so we can also ditch the, let's say, null part. Let's build. let's build what? Of course, let's build something out of it. Let's build a route param and query param that are signals. And in order to get that, we use most of the time activated route. We say inject activated route, do get params, subscribe, from params get one of those keys. So let's say we have a function. Remember that function that we had before. Let's say we have const route or activated route where we inject now activated route because we can do that. And of course, at the same time say, I want to return a signal. And that signal can come from route params. Of course, I want it to be based on some key and then say, I just want to put a map there and say, get that key. Now with this, I can say, hey, I can also have query params. So just like route param, I can have a query param that's also a signal. And with it, I can say, if I'm on user details component, I say, I want the user ID, and that user ID is just a route param with that key. Or if I want the, let's say, query param of search in my user list, I just get that from the search key, and then I have search query now as a signal. As we can see, these are just read-only signals. So can we have query param with two-way binding support? As I said, we have that synchronization mindset. Well, yes, we can. I've built that, let's say, utility, and it's called link query param. And what it allows us to do is say, I want a writable signal on this query param key, in our case, search. What this allows us to do is say, every time I read search, I get that query param. I can use it everywhere, my forms, my data, signal store, Rx, Angular state, everywhere where you can, let's say, use signals. But also, if I write to it, what it does is it says, OK, router navigate, but with this new value of my signal. So it basically does two-way data binding with query params. Of course, we can say, I want to parse stuff, because on query params, we can only store strings. So you can say param to number, pass maybe some default value for page. Or maybe you have a resource, and you want to use that. So you basically can synchronize your query params directly with an API call. And every time that, let's say, query param changes, you know that Rx resource will take care of it, because that's how signals work. Angular tries to synchronize everything. We can use that with booleans, numbers, objects, arrays, and everything just, let's say, synchronizes itself without us having to care too much. That's part of ng extension library. It currently has 43K weekly downloads. To me, that's a lot. And it all thanks to all these contributors. Probably you can't read their names. It's too small, because there's too many there. And let's see a demo, short one. I have an Angular app called Angular Movies. And of course, I can open the side drawer and close. But let's say I want to retain this state because, hey, if I open the sidebar, if I refresh the page, I still want the sidebar open. And if I do that, it gets closed. So I want to synchronize that with my query params. If I look at the code, I have side drawer open that just stores it in a signal. A writable signal that the moment that we destroy our application, like refresh the page, that state just gets destroyed. What I can do to it is say, hey, I want it to be a link query param to my side drawer open key. And of course, here, I have to say every type, because this is now type string or null, but I want it to be a Boolean. So I can say parse param to Boolean and be like, hey, I want it to have a default value of false. So by default, it's closed. But if there's something in the query params, hey, keep that state first. If I go on the page, refresh just in case, open it, as we can see, we have side drawer open set to true. If I refresh the page, that thing stays. Of course, normal behavior. And we can see that side drawer open is used inside my template, inside this UI side drawer. But we can see there that that's two-way data binding. So we have two-way data binding into another writable signal that also does to a data binding in 1 minute. So we have a signal which synchronizes to another signal, and that's Angular's job to do. But with our function, we can say, hey, I can give you more knowledge about the outside world in a signal's form that you can change and update like a normal signal. And of course, that's great. What else can we do? We can say, hey, I just don't want this only on query params, but maybe I want this to, I don't know, retain it somewhere else. For example, I have dark mode. If I have dark mode, I want this every time I change this or if something changed. I want all my tabs that I have opened to also have dark mode there. So I want to synchronize this with my local storage. So if I go on my application and be like, please, dark mode, that is just a normal signal, I can say, be connected to local storage. And I can say, please synchronize every time you change. A default value of false. On storage, we can store strings, but we want to parse it. So I say, if the value is true, then probably the value is true. So dark mode enabled. Stringify is basically telling, just stringifying that thing, nothing special. And dark mode, of course, is also part of two-way data binding here. And the component itself uses a normal model. So normal Angular code. And now, if I go and change my dark mode, it changes on both. So we just synchronized two tabs. And that, my friend, is what I have. Thank you very much.